Hi, ladies and gentlemen. It's Mr. Young back again with more exciting mathematics and even better than just mathematics. It's factoring mathematics, which you're excited. I know you are. It's okay. It's going to be good. We're going to go over how to factor again. I'm going to give you one example, the magic X. And then I'm going to show you something called the zero product property and how it's going to help us solve these equations that we did yesterday or in the previous lesson by graphing. And we're going to do it more algebraically. So you guys remember this, right? Magic X, 3x squared minus 17x plus 20, okay? And I check for greatest common factor. There isn't one. We're good. And then I figure out that A is 3 and B is negative 17 and C is 20. And then I draw my X and I put A times C up top and B in the bottom, right? So 3 times 20 is 60 and negative 17 is just negative 17. Then I have to find the factors of A times C that add up to B. So factors of 60 that add up to 17, sorry, negative 17. And we talked about how I usually list the factors out and they're all positive. If you've got your factor sheet, which you should, they'll be all positive. But since I need these to add up to a negative number, I'm going to need them to all be negative. So I'll have negative 5 and negative 12 adding up to negative 17. You can check the rest of them. None of them work. Once I know that, we call one of them P, we call one of them Q. So we have P is negative 5, Q is negative 12. Order doesn't matter here, so whichever one goes wherever. Then I take that X plus P, X plus Q. These are going to be my binomial factors. I plug in P, I plug in Q. They become negative because they're both negative over here, right? Divide and slide was the next step, if you remember that one, right? Divide everything by A. Okay, simplify the fractions if you can. Here we can, here we can't. And then slide the denominator up front if we still have one, which here we do. So we end up with 3x minus 5 times x minus 4. That's factoring, right? I made a 22-minute video over that, and I've covered it now in about 1.5 of those minutes, maybe 2. So if you need to review factoring, go back and watch the 8.6 videos. There's 8.6a and 8.6b. I took this slide right from the 8.6b video, I believe. So you can go check those out again if you need to. But otherwise, yes, that's how we factor. And with the factoring, we're going to use this thing called the zero product property. Now, here's what the zero product property tells us. It says if we have two numbers, A and B, and you multiply them together and they get 0. So A times B equals 0. Then one of these two things must be true. Either A is 0 or B is 0. Okay? That has to be true, right? If I have something times something equals 0, one of those somethings must be 0. And this is helpful to us because if we think about this, this still means if I have x plus p times x plus q equals 0, right? So in other words, I have a factored trinomial, then either the first factor has to equal 0 or the second factor has to equal 0. One of those two things must be true, right? You would consider this x plus p, that's like your A. X plus q, that's like the B, right? A and B, one of those things has to be true, all right? And when we talked about how if we graph quadratics, they always have two solutions, right? Because they're going to, not always, they oftentimes have two solutions because it crosses the x-axis twice, right? It goes down and then comes back up through the x-axis or the other way around. When we talked about that, that's how we get those two answers graphically. Here's how we get those two answers algebraically, all right? So here's what it's going to look like, right? We're going to take that 3x squared minus 17x plus 20 equals 0 now. And to be clear, this is the same that it was in the previous example. Like I'm just using that same problem. We're going to take this. We're going to take the polynomial part of it, put it through the magic X, rewrite it in its factored form, 3x minus 5 times x minus 4. So we've already talked about how to factor this. We just did this in the previous example. We've got it in factored form. But now since it's equal 0, I have to solve it. So I have to figure out which values for x is going to make this true. And I do that by setting each factor equal to 0. 3x minus 5 equals 0. That's the first one. X minus 4 equals 0. That's the second one. Okay. Each factor equals 0 equals 0. And then what's kind of nice about this is now I just have to solve it, right? So I just have to get x by itself. So what would I do? I would add 5 to both sides, get 3x equals 5, and then divide both sides by 3, x equals 5/3. And then down here, x minus 4 equals 0. Add 4 to both sides, and you just get x equals 4. So if I get an equation, right, 3x squared minus 17x plus 20 equals 0, that's the new part, well, then I'm going to factor it like I've been doing in chapter 8, keep it equal to 0, but then take each factor separately and make each factor equal 0, all right? And that's legit the only new thing we're doing, right? Everything else is just stuff that we've done, right? It's just more factored. It's stuff that we spent the second half of chapter 8, like 2 full weeks, we just did factoring. Well, now we're going to do one more thing after we've factored. We're going to set the factors equal to 0 and then solve basic linear equations. And that's really all it'll be. Now, you will see some other interesting things just to be on the lookout for. The first 3 or 4 problems are already factored, which is kind of nice. You don't even need to use Magic X. They give it to you. It's like x plus 3 times x minus 5 equals 0. If I see those 2 sets of parentheses, I already know it's factored. So now I just set the first factor equal to 0, x plus 3 equals 0. Second factor, x minus 5, also equals 0. And then I just solve each of them, right? Subtract 3 from both sides, x equals -3. Add 5 to both sides, x equals 5. And I'm done, right? These are actually the easier problems because I don't have to factor. They've already given it to me factored. There's actually less to do on these problems. Why do I keep saying it? Because every year when I teach I get like a lot of questions like, what do I do? Like the first part, the hard part is already done. It's already factored. You jump right to the end. How nice. You might also see a monomial factor. Now I scanned over the homework real quick and I know one of the already factored ones looks like this. You might also run into something like this if there's a greatest common factor, right? So if you had to like factor out an x before you did Magic X or something like that, you might see something like this. But I know for sure there's at least one on the homework where it's already factored and one of the factors is just a monomial, right? There's only one set of parentheses. But this is still a factor, right? This is still x, that's A, times x plus 10, that's B. So I still set both factors equal to 0. X equals 0, that's my first factor, and it's already solved. One of my solutions is 0. This whole thing equals 0 if x is 0, because you get 0 times 0 plus 10, which is 10. 0 times 10 is 0. So I set the first factor equal to 0, and it gets x equals 0. That's a solution. That's one of them. The other one, like we did before, x plus 10 equals 0. So we get, subtract 10 from both sides, x equals 10, or negative 10, excuse me. Okay, so you'll see a problem like this. And then also we mentioned this, I want to say in the graphing section, or the solve by graphing section, they will give you some where they say solve, but it's not set equal to 0 yet. And when we're solving by graphing, especially since we're using Desmos, a lot of us, you can skip this, but with the factor, you absolutely must set it equal to 0. It will not work if you don't set it equal to 0. Or if it does, it's going to be, you got to set it equal to 0. Just take my word for it. You got to set it equal to 0. So we're going to start by adding 8 to both sides, right? So we get the x squared plus 9x plus 8 equals 0. And then magic x, x squared plus 9x plus 8. And I didn't bother magic x in it, but take my word for it. It comes out as x plus 8 times x plus 1 equals 0. And then set each factor equal to 0. X plus 8 equals 0. Subtract 8 from both sides. X equals -8. X plus 1 equals 0. Subtract 1 from both sides, x equals -1, okay? That's it, right? This is how all the homework is going to look. I think I covered everything, especially with this last slide here. If you have any questions on how any of these work or you get stumped on any of them, feel free to reach out. If you're struggling with Magic X, like I said, check those old videos out first, right? Not that I don't want to help you. I just feel like when you go back and watch an example or two again, you're going to go, oh, yeah, that's right. Find your notes, use those again, and you should be in good shape. If you do have questions, reach out. I'll take care of you. I love you guys. Thanks for watching. We will catch you next time.